Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. RudderStack is the smart customer data pipeline. Easily build pipelines connecting your whole customer data stack, then make them smarter by ingesting and activating enriched data from your warehouse, enabling identity stitching and advanced use cases like lead scoring and in-app personalization. Start building a smarter customer data pipeline today. Sign up for free at dataengineeringpodcast.com/rudder. Your host is Tobias Macy, and today I'm interviewing Vinoth Chandar about Apache Hudi, a data lake management layer for supporting fast and incremental updates to your tables. So Vinoth, can you start by introducing yourself?
First of all, thanks for having me here. And it's a great show, and it's a pleasure to be, an honor to be here. My name is Vinoth, and I am the PMC chair for the Apache Hudi project at ASF. I started this project born out of Uber in 2017, and I've been supporting the open source community for the past 4+ years. And yeah, I'll really look forward to talking through the project's journey today.
And do you remember how you first got involved in data management?
Oh yeah, definitely. For me, my real interaction with this ecosystem was during my employment at Uber. I was a database guy. I'm still like a database guy. Started my career with Oracle, and then working on their CDC products, Golden Gate Streams, and then moved on to LinkedIn, where I led the Voldemort Key Value Store project for almost 3 years. Then at a brief stint at Box, again building some version of Firebase for them before that project was scrapped, and I moved on to Uber. But even after Uber, recently, I was a principal engineer at Confluent, spending time turning KSQL into KSQL DB, spend time on Kafka storage. So for me, I'm a database guy, tried to build, I really wanted to do big data analytics and the whole Hadoop stack back in the day, if you will. I was an early engineers. We built out the data team. This was the hyper growth, hyper scale years of Uber, 4xing every year, and launching cities every day and all of that. Yeah, we built open source stack. We brought Kafka, we brought Hadoop, we got Spark, HBase, Presto, everything. And after a year or so, we had a functioning data lake. Things were okay, except for the fact that we were doing so much data management in DIY data management in the lake, no transactions, right? And then large batch jobs. And yeah, essentially we decided to do something about it, and I got sucked into that. And I've been in that thing for almost 5 years now.
That kind of leads us up to the motivation for building Hudi. So can you dig a bit more into what it is that you built there and some of the problems that you were dealing with at Uber that led you to building this new system?
Yeah, so what we did was, I honestly wasn't trying to innovate anything when we started writing Hudi. What we wanted to do was, if you imagine Uber is a very real-time business, right? So building for the data products within Uber is very different from even, let's say, LinkedIn, right? I came from LinkedIn. LinkedIn is a brand in terms of data infra contributions to the industry. But at Uber, you have 10,000 plus people who operate at the cities, and you almost had to build products like you're building for external customers. So the bar was pretty high. You had to get real-time data. And we had managed to, get change logs from all databases, collect Kafka event streaming data, schematize everything. Data was streaming up to the point that it had to be ingested into the data lake. And then when you tried to do that, you had no good mechanisms to sort of apply your database CDC logs incrementally onto the data lake. And furthermore, you had to do these large bulk batch jobs. We stood up HBase, and we streamed all these CDC logs into HBase, and then we would dump HBase into Parquet every X hours. It's pretty time consuming, extremely resource inefficient, and then it doesn't give the latency that we want, right? And it doesn't stop with just the ingestion. And we noticed that it was a more systemic problem where, let's say you have the core trips data to Uber. You can imagine how many, entire company wants to query that, right? But there'd be like derived tables that you would build of the core trips table, which are, all are again batch jobs, like large recomputations. And there is no intelligence in this model, in the batch processing model, to say, you know what, the upstream table does not have any data, don't run it. Only reprocess these records. These are the only records that have changed upstream. You don't have to recompute the entire thing. So as a result, we could neither meet our data latency, kind of like promises to the company. We were bleeding a lot of hardware in terms of Hadoop jobs that we are running to kind of like bake and do these data sets. And we rethought this problem. We even considered systems like Hive Acid back in the day. We couldn't really do it because it's so tied to Hive. And as we talk about later, some of the storage layout properties we didn't like, and looked at things like Kudu were coming up at that point, and it was promising. But the thing is, you had to move this entire stack outside. It's a new storage system which needs a new hardware stack. It wasn't very cloud proof. Tomorrow if we wanted to store all this data in the cloud, so it led us to a point where we were like, let's think about how we even solve this before we brought all this into Uber, which is we had Vertica, right? And then Vertica had transactions updates. And then, we said, okay, all we need to do is build a transactional layer on top of, HDFS or the Hadoop file, like a cloud storage kind of abstraction, and then provide update deletes. And then as a, drawing for the derived data problem, we were like, okay, how do people generally solve it? Like people write stream processing pipelines, which process data incrementally. And how is that done? That's done by something like Kafka providing you first class ability to, efficiently consume only incremental changes from like a topic, right? So we brought that incremental change stream CDC from databases and Kafka to this world. And that's how Hudi was born. It was created as an abstraction which provided update deletes and incremental changes from tables. And we use that first pass to kind of completely make all of our ingestion and our core kind of derived, the warehouse ETLs, if you will, be like completely incremental. That's the story.
Yeah, it's definitely a very interesting project. And this is an interesting time in the overall ecosystem of data lakes because, as you mentioned, Hadoop sort of reigned supreme for the early to mid 2000s and then started to fade out as things like S3 gained more prominence and other engines built on top of the actual file system layer were built up to give more of a database type abstraction, and the MapReduce paradigm went away. And so in the past 3 to 4 years, there have been a number of other table formats that have come to the fore, Hudi being one of them, other notable entrants being Iceberg in particular, and then Hive has been around for a while as kind of the sort of table stakes for that space. And I'm just wondering what your perspective is on the current state of the ecosystem for table formats, for data lake engines, and sort of the overall role that these different metadata and schema management layers play in the overall storage and processing ecosystem.
Right. This is a very big question, and also I think something that everybody wants to hear about as well. So if I may, I'll take some time to break this down and explain in layers, if you don't mind.
Yes, please.
So first of all, right, this whole like table format, the term is kind of new, right? I mean, essentially, first, so it may be helpful to first define what that is and kind of push in Hudi relative to kind of like some other formats out there, right? So file format has a schema. It gives you ability to write and read data, right? So table format you can think of as something that tracks a schema for a table, some partitioning information, some statistics for the table. That's basically what its role is to be, and also provides a concurrency model around it, so you can change this data with some guarantees, right? It's more about the metadata around the table. And when we look at Hudi, we never thought about Hudi as a table format and neither designed as a table format. Hudi is designed more like a database that is built or on top of these table formats, if you will, right? It comes with indexing, it comes with like a redo log, and then like databases have daemons, right? Like which all do like various things to make the database functional and also optimized and performant. So it comes with a set of daemons who all like know about each other. They're all working off of the redo log. And a format is like one piece of the puzzle. And Hudi started by simply adding transactions, updates, and change capture on top of the Hive format, if you will, right? Hive tracked schema, partitioning information in the Hive meta store, but it couldn't really track anything that's scalable around, file level statistics. That was the biggest gap, right? And our file listings, for example. So for us, contrary to what I've heard from other format designers, it's actually doable to build a transactional layer on top of the Hive format. That's what we did. Like we've shown it that can be done. Like a 200 petabyte data lake has been running for 5 years like this, and then many companies have done this as well, right? And to the earlier point, right, we actually have a Jira open for almost 2 years now to say, hey, can we plug in something actually also open under the same Apache umbrella like Iceberg as an alternative? Just like how we sit on the Hive format, can we make the databasey stuff of Hudi sit on top of Iceberg, right? So that is something that we remain open to, and then it just been like a resourcing thing, right? So end of the day, to summarize, I feel table formats are removing decade old kind of bottlenecks in terms of metadata access around the tables. It's still a means to an end. That's kind of like how I look at it, right? Now, going down into the actual issues around table format. The Hive format does have its issue, like you mentioned. Doesn't like track anything file level, folder based partitions, which are very kind of like, pretty rigid, right? And then poor or no concurrency models. And I think when you operate in cloud environments, especially and with large tables, you face all these like listing issues, right? Or when you try to scan large tables, small tables are okay, right? So over time in Hudi, we also hit the same issues, and we extended the Hive format with our own native, like kind of like, Hudi implements its own table format internally, which, for example, stores file listings, some statistics, similar to what like Iceberg and Delta have done. But we try to design for our original goals of, hey, we want to enable, kind of streaming model of writing and reading data from the data lake, which means Hudi's for table format optimizes for smaller files, which means a lot of metadata. So we indexed metadata in our table formats. And we've been actually building our table format, I'm saying, for a different purpose, which is more in line with the overall goals of Hudi to, unlock kind of incremental data processing or like kind of change batch processing, like more general purpose across the lake. With this context now, thanks for being patient. The actual similarities between all three projects provide transactional like inserts and versioning and point in time queries. Delta Lake and Hudi have supported updates and deletes for almost 3 years now. It's been out there. I think Iceberg has a V2 format for deletes, which is nearing completion as I understand it. But the differences, I'll try to touch upon a few major areas. If you look at storage layout and how you actually version and store data, Hudi actually, day one, we started supporting two kinds of laying out data. One is copy and write, you just keep versioning Parquet files, and merge and read, where you actually have delta logs when you're trying to update a table, and then you merge on the read side, right? So we actually see these terms now used even across, like Delta talks or like Iceberg community and stuff. So talking in those terms, Delta does not have the MOR capabilities yet, right? Ironically, there are no Delta logs inside Delta Lake. Iceberg V2 modeled around the Hive ACID layout, where you keep like log files which are more global to the partition or a table. Going back, since we want to optimize Hudi for very fast upserts, we bucket the delta logs. We have an indexing mechanism where we map every single incoming record to a single file, and then we break down these deltas and push them to individual files, which helps us actually reduce the overhead of merging, and kind of like the amount of data that you scan during merge and read is lower in this kind of layout model. These are some things that are different at the storage layout level. You will get different performance for different workloads with these three formats, right? Concurrency, both Delta and Iceberg support what is called optimistic concurrency control, which essentially means I'm not going to expect concurrency. If there is concurrency, one of them will succeed, the other one will fail. The problem with this approach, when you mix with long running transactions, which is what batch jobs are, right? When that you write across Delta or Iceberg, the longer the batch job runs, the higher the probability of collision. Just theoretically speaking, right? And then these jobs run for a long amount of time. They waste a ton of CPU, and then they finally one of them fail. Right? So from early on, we've embraced a more MVCC model. Just like a database, we differentiate between internal daemons and then actual client writers to Hudi, where writers may get optimistic concurrency control between them, like one of them can succeed, one of them can fail. The internal services like clustering data, compaction, anything that is maintaining the table can run in a completely non-blocking way. So you can keep writing to changes to a file as we compact data in the background. And this is, I think, very key if we have to really deal with mutable data at large scale. I feel like the core design for kind of like batch formats like Delta and Iceberg are they're more designed for append only workloads, in which I think OCC may work fine, right? Whatever I'm talking about, when you have a lot of deletes or updates, when your core ingestion updates, these problems will show up at scale. And then most of these design choices that we made in Hudi are made for running some high scale like data lake, like something like Uber, right? Where you cannot really violate the SLA of the rights that are updates that are, we want to replicate the trips database very quickly while there'll be deletes to the trip table because, some user left the system or GDPR or like something happened, right? So how do you like accommodate these two things without locking and blocking and timing out and retrying? That's where Hudi really stands out. And the design is kind of like, these are like very key database design differences, which sometimes don't get bubbled up as much in the kind of the data lake ecosystem when you simply look at it as a format, if you will, right? The other interesting thing is we add record level metadata and then the incremental query part of it, right? So Delta Lake has incremental queries, but we actually track record level metadata. If you go back to stream processing concepts, there is event time and then arrival time. We actually track both for data that is written in Hudi. So we are actually able to give you like, a Kafka like experience when you say incremental query. You'll only get so with Delta, I think my understanding is you can get the files that changed. When you diff Iceberg snapshots, you can get the files that change between snapshots. But with Hudi, you get like record level CDCs. And then we have a ton of metadata internally that we track to build, trigger watermarks, which something like Flink can eventually understand. So we are like building towards that feature. Finally, looking at it as a project, right? The actual software that's in the project, looking at it just like a table format doesn't like account for all the platformy components that we have. We have, just like how Kafka doesn't just give you a pub/sub system, it gives you connectors, it gives you monitoring, it gives like a bunch of things around it that you can take and deploy and actually use Kafka for free, right? In your organization, Hudi has built like ingest tools, ETL tools. It can do out-of-box deduplication of event streams before ingest. A lot of upper level functionality that has been built on layer on top of this like kind of database layer. That's what you get today in the project. And these are all, thanks to all the great work that has happened in the open source community. We didn't have much of this when we, open source the project from Uber, but all of this has been built. And that's again, like something to highlight the power of open source and like how much we can do together here.
Given the level of functionality and the number of different capabilities that Hudi introduces to the data lake ecosystem with these database-like capabilities such as MVCC, where you can have a snapshot view of the state of the data during the lifetime of your transaction, and the ability to manage arbitrary updates and deletes of records within the table space, which is something that has historically been challenging. Because of this fact, it starts to look more like the sort of so-called lake house architecture that has been sort of gaining some popularity, at least in terms of the nomenclature. And I'm wondering, with what Hudi is bringing to the data lake ecosystem, what do you see as the current dividing line and motivating factors between a data warehouse, particularly with cloud data warehouses, and data lakes, given things like Hudi and some of the overall processing engines that are out there. Like, the lines are starting to blur a bit more. So as somebody who's working in the space, building this data lake capability, what do you see as sort of the motivating factors to land on one side or the other?
First, on the lake house, the idea of a lake house, right? And I think it's a pretty neat way of putting this. When it first came out, I actually at least wasn't like that surprised, because I've worked on two companies now where both at LinkedIn and Uber, like, large data companies with a lot of open source. That's how we built it, right? You get your operation system, you first, store in open file formats. That's what you use for analytics using something like, Presto. And then the same thing, the data gets fed for machine learning. I think Databricks has done a really good job of like elevating this as a term. And then kind of like, now we have a reference point to talk about it. So I think good amount of credit should go to them for kind of up-leveling the conversation in the industry around this. So the vision for a lake house, though, right? When I think about it, when I compare it to the warehousing, the cloud warehouses, right? I do feel like cloud warehouses and warehouses in general are perceived as a much more usable product end to end. And this is something that on the lake space, we keep, I mean, I'm including myself also in that thing. We keep focusing a lot on the technology, but then warehouses make it very, very easy for users to onboard and use it, and even with all the other gaps, right? So the part of the lakehouse vision is that Delta Lake installed in Databricks or Hudi installed in EMR, you can go and build your own lakehouse, right? But with Snowflake and BigQuery, you don't have to build that warehouse. It's built for you, right? So these are the things that we've slowly tried to change with Hudi to build more and more components and make it like as much as possible like a single stack that people can take and deploy and monitor and operate. But I think this level of usability and user experience has to be built around the lakehouse, even with the technology gaps, I feel. That is, I think, super important if we are to really unlock this thing at scale. All the large tech companies may be able to hire a lot of good engineering talent and build these kind of things in-house, right? But for like a company who's starting out, right, who is trying to grow, like they're not going to be able to hire. They want something that's readily available, a lakehouse that is like readily usable, and they can like, it's a turnkey solution. You can do it and then it works. Then we go into the actual technical differences between architecturally cloud warehousing versus the lakehouses, right? I essentially see one major difference, one major limiting factor, which is running ML and data science workloads on top of cloud warehouses in a cost efficient way, right? And let me double click on it. So when we say that, what we really mean is a good chunk of ML data science is writing, jobs to feature engineering, right? Scanning large amounts of data, correct? So data warehouses are best in class, I feel, in terms of, even as engines like Presto and Trino are like constantly catching up to them, right? So the problem of querying data is about reducing the amount of data that you scan so that you can return the results very quickly, right? But the job of data science and data engineering workloads is to score through large amounts of data very quickly, right? And then extract new things. So if you look at, let's say, even Snowflake, if it's still the same, right? Last I checked, the largest cluster that you can run is 128 nodes, right? And at that point, you're already paying a very high cost for that ginormous cluster. If you want to do data science on it using Spark, you need to pay for like a Spark cluster, keep a Snowflake cluster running, access data through that, right? This is prohibitively expensive for anyone to do, even at like moderate scales. So I think the technical gap remains, can warehouses, actually cloud warehouses, really support the cost effective and scans in terms of for data engineering and data science workloads? I see as the core kind of like technical advantage that you have on the lake house or data lakes today versus the warehouses. Of course, there is openness, right? I don't believe that, even if I have to go back and do it, even if we solve this scaling problem in the cloud warehouses, I still feel like, most of the data should be kept in an open format, like data format, like, Parquet or Varsi, managed by open table formats, if you will, that all that we discussed, right? And that's the better future for most companies to be building towards, right? And then we should go back to this model where these are all external tables in a cloud warehouse. So if you want really the price performance of Snowflake or BigQuery, you move your data in to the native format. Otherwise, you keep it in Parquet, right? And this, I think, is a better future for us to build towards. Just the openness. It gives everyone like a lot of choices, right? And it generally fosters better innovation, I feel. You're not beholden to one company adding more support for a particular framework to access your data efficiently, right? Yeah, so that's how I generally think about this landscape in terms of this. Data lakes need to fix a lot of things around usability and experience and like do more out of the box. Data warehouses have to like get over some of the cost scalability issues around accessing large amounts of data. Still, I think we should have a model where we have open data, right? And that's what the industry should be building towards.
Yeah, I definitely agree on all of those points, especially about the sort of usability and access layer for the data lake, because that I think is the piece that's still missing, at least in the open ecosystem, where there are some companies that have built that layer on top of open formats to make it easier to manage data lakes in an organizational capacity. Whereas if you want to put together your own stack from pieces that you pull off the shelf, there's a lot of engineering to do. And so I'm definitely interested to see sort of how that evolution progresses. And as data lakes move more towards the usability of cloud data warehouses, and cloud data warehouses maybe start to add extensibility to support more open formats, because that's definitely one of the things that always gives me pause as I start to look at things like Snowflake or BigQuery is, okay, I can do this and I can use it, but then all of my data is beholden to this company until I pay the, expensive cost of then exfiltrating it to a different system down the road.
I think if we can spend like another little bit more time on this topic, right? I think, yeah, that is the part that I feel like if the data lakes don't fix this problem in the next few years, people have the need though, right? The data volumes are increasing. They can't really afford to build a lot of this themselves. Those things are pretty clear. So this data has to go somewhere, right? So if it's not the lake, then we will be in that situation. And for me, working on the Hudi community for like 4 years, and I spend time on daily basis, like looking at what people are doing in the community. I can see people, right, who are data engineers in their companies. They're really good at writing Spark jobs and like writing business logic, a fraud detection pipeline. They can do an excellent job with writing that. A lot of those engineers are suddenly tasked with, hey, build out the data lake for this entire company. And then what happens is they need to know, like, it's not just about a technical problem, right? You need to grow a lot of data engineers from to platform engineers. That's a very rewarding journey for the individuals who are trying to do it, right? Some of them come out with flying colors, but some of them don't. And for the company, it takes a long time to get ROI on these projects because a lot of the platforming components aren't there. And going back to Hudi, if you take one example, right, we have this tool called the Delta Streamer tool. We just named Delta Streamer even before Delta Lake came out, so it has nothing to do with Delta Lake. But anyways, so it makes it very easy for you to ingest, Kafka topics into like S3 Hudi table by, issuing a Spark submit command, right? And then if you run it in a continuous mode, it can do clustering for you. It can do compaction. All of that is like self-contained within that single Spark job that you submit. And then people seem to really like it because, get like consistent monitoring out of it, right? So you kind of like tooled away one at least large use case, and then you're able to, hit the ground running and show some progress to your organization much more quickly. I'm not saying this is the ultimate thing and we've solved all of this, but I definitely see that more than the tech even, right? I think this is where the data lakes have to focus all their dollars on.
Now, digging more into the Hudi project itself, you've mentioned a little bit about some of the architectural elements as far as supporting MVCC and having the sort of compaction layers and copy on write versus merge on read. But I'm wondering if you can just give a bit more of an overview about how the overall Hudi project is implemented and the different moving pieces and the components that are necessary to deploy to get it actually set up and functional from an end-to-end perspective.
At a bare minimum, what you need to do to play with Hudi is you need a Spark shell and S3 access to S3, so you can write some data and then update the data, delete the data, and query it all from here, right? But a typical setup looks like this, where you have some upstream data that you used some tool. Let's say it's all sitting in some Kafka topics or some files that are getting uploaded to other S3 buckets. Then you run the Delta Streamer tool, or you can write your own custom Spark jobs, Flink jobs to read that data and first ingest it onto a bunch of raw Hudi tables and register them out to Hive Metastore, Glue Catalog, or Google Cloud offers you a managed HMS in some Metastore, and then you're able to now query this data in different ways from all the major lake engines, right? Presto, Spark, Trino, and also managed solutions like Athena from AWS, Redshift, and like even Impala. I think we support Impala copy and write as well. So that's how the overall layout looks, right? And then going one level down, right? Let's try to just understand what happens on the writer side, how files are actually laid out in storage, and then how actually then queries actually access this data in a consistent way. So first talking about storage, right? So what Hudi does is, you can have an unpartitioned or a partitioned Hudi table. For simplicity, let's take like partition example. So essentially you write data, and then let's say you're inserting data, it produces a bunch of Parquet files, right? Then we call each file is assigned like a unique UUID, which we call a file ID. From there on, if you now try to update any update to the individual Parquet files, for merge and read storage type, it is stored as a delta log, which is associated to a given file. For each file, we essentially call this combination of base file and the delta log as a file group. For copy and write, for example, we don't write delta logs. We implicitly, merge the log into the Parquet file and produce a new Parquet file. So essentially, what you will see is data is grouped into file groups where each key, a record identified by a key, is at any given time mapped to a single file group. And then within each group, you have these slices of data where there's a base file, a bunch of log files, then maybe a compaction runs and produces a new Parquet file, which is a new slice of data, right? So this is the MVCC kind of storage model within Hudi. So all actions, commits, deletes, updates, all the background actions, we have, compactions, like remove older file slices as you write more and more data, and to keep the storage growth bounded. There's a compactor which can take the logs, merge it with the base file, produce a new base file. Clustering, which will now look at a bunch of file groups and say, I'm going to Z order these things into a new set of file groups. So all of these things work on a single event log, going back to our inspirations from stream processing. And they all are materializing their plans for compaction, for example, for clustering to a folder under each table, what we call as the timeline. And then that's the source of truth redo for this entire database. So all these background services and writers do coordination based on events that they see in this timeline. And what happens today is, for talking about all these extensions to table formats that we need to build, this timeline is then kind of replicated into an internal Hudi table, just like how let's say Kafka uses internal topics to store schema and offsets and stuff. And we make listings, we make statistics, we make like tons of metadata around the table. So that's the storage layout, how it works. When you're writing, the write pipeline can natively support something called pre-combining. Here is the use case for something like that, right? Let's say you are obtaining change logs from an upstream database. Within a single run, like within a single batch, a record may be updated many times. Say, for example, a Uber trip ID is the primary key, then you get many updates to that same trip. People need a way to combine these into a single record before they apply it on storage. So the first step for the absurd delete operations is to combine these change logs that you're getting into a final form. Then we look up an indexing scheme, which gives us a mapping between a key and the file group. And we support external indexes. We support like join based index. We support like indexes using Bloom filters. And we have PRs out for record level indexing. So this is something just like a database, right? This is an example for functionality that Hudi builds on top of like a table format. The second step is, so the indexing step tells you whether it's an update or an insert. If it's an insert, we create new file groups. If it's an update, we either log deltas or we produce new Parquet files. Right. So the final stage is actually writing the data out, and we do many optimizations here to sort the data so that it can compress better or it can provide more locality for queries. Like for example, in the Uber example, we would want to sort by city IDs. If, let's say, data scientists are always working based on city IDs, they're querying always by city ID, or dashboards are plotting stuff for a given city. Before we ingest, we want to sort it by city IDs, right? So that you scan less amount of data. So these kind of storage layout optimizations happen, and the data is finally written out. For the queries, let's take a Presto query, right? Presto query is going to actually see it as a Hive table pretty much. And then within Presto, there is a point where it says, hey, I'm going to do everything like how I normally do things, except I know this is a Hudi table. I'm going to go look at the timeline. I'm going to figure out what is the latest committed, transaction is. And then I'm going to actually now filter all the files, regardless of whether this listing comes from Hudi's metadata or actually you list S3 or HDFS. It simply does filtering and then exposes the latest snapshot of the table for you to query for snapshot queries. When you look at something like Spark, we support a lot more flexibility where you can either query it as a snapshot table, or you can say, give me records that changed after 8 a.m. And then we can give you records after 8 a.m., right? And you can also do a point in time query where you can say, hey, give me records in the past, which are, like a month old. Then what we can do is we simply let you query that file slice that was written back then, as long as you retain it in history. So we expose a lot of flexible ways to query the data. And specifically talking about MOR, we support one additional view of the data called read optimized views. So this is a very practical scenario where normally you want to keep all of your data in Parquet tables, right? You have like date partitioned event logs or something, which is like everywhere. And then you'll get sporadic deletes that you want to kind of log in the delta logs and then compact them later. For those kind of scenarios, we offer an additional view for the query engines, which only query like the base Parquet data. So you get great columnar performance without any of the merging overheads, right? And as long as you design a compaction and it works for a common use case like this, then you actually get best in class columnar queries for recent data, while Hudi's indexing and like the logging and the compact asynchronous compaction keep things like data deletion and everything kind of like chugging along without affecting queries or even affecting ingestion jobs, right? This is actually how we pulled off data deletion at like hundreds of petabytes of scale at Uber, because we cannot take logs, so we can, like, going back to our previous conversation, right? So these are some common scenarios in which you use it. And all of these background services can be run on an external workflow scheduler like Airflow, or they can be run inline with every write, which will add latency to the write, but it's simpler. Or it can also be run within the same process, the writer process, but it's been done in a asynchronous way. So for example, you kick off Spark streaming job, it's writing data from Kafka, but it's also like using the same Spark's like internal job pools and everything to intelligently schedule clustering, compaction, and also do all these like background tasks done. Again, like how, let's say, for example, RocksDB or Berkeley DB would behave if you embed it within your application, right? It'll be running some background threads which are like cleaning, compacting. Similarly, Hudi can self-manage all of this for you.
We've all been asked to help with an ad hoc request for data by the sales and marketing team. Then it becomes a critical report that they need updated every week or every day. Then what do? Send a CSV via email? Write some Python scripts to automate it? But what about incremental sync, API quotas, error handling, and all of the other details that eat up your time? Today, there is a better way. With Census, just write SQL or plug in your DBT models and start syncing your cloud warehouse to SaaS applications like Salesforce, Marketo, HubSpot, and many more. Go to dataengineeringpodcast.com/census today to get a free 14-day trial. In terms of alternate write paths, where right now Hudi is fairly closely tied to Spark, what are the options for people who might be using a different processing engine or a different input workflow for being able to populate files into the Hudi ecosystem?
Right. So the one thing I probably missed out is that you can do Spark and Flink today, not just Spark. But yeah, this is one thing where since we did not design it as a generic table format that you would want to write data from every engine, right? We basically picked Spark and something that people most data pipelines in, right? And that's how we did that. So we are still working on, for example, how you would write data from Hive. We need to write a storage handler, and for Presto and Trino as well. In the coming releases, we are planning to add write capabilities from that. For now, Spark and Flink is how you write, and then you can query from everywhere else. The reason is, again, Spark and Flink are more general purpose, DAG. You can write more general purpose DAGs. All of this great functionality that I talked about, where I can keep like a thread pool, a long running Spark streaming job. I can do pools. I can do indexing, which needs like shuffling of data, right? All of these things we are able to do with full fledged data pipeline processing frameworks like Spark and Flink, whereas with more SQL based, writes, for example, in Hive, the output format, if you want to do updates, we are not able to do the indexing step there. We have to do this pre-combining indexing, these additional write pipeline optimizations. We are not able to do it there. So we picked like initially the major data processing engines, and we just try to optimize this runtime to work really well on those. And we are looking into that, but that's how things are today.
And then another thing worth digging into a bit more is the capabilities around arbitrary updates and deletes that we touched on earlier. But I know that that's a challenging problem, particularly in data lake ecosystems, because of the write amplification, where a delete in one record in one file might then propagate to arbitrary downstream files because it's a data dependency in other table structures. And I'm wondering how the architecture of Hudi helps to make that a tractable problem without having the deletion of a single user record then causing you to have to rewrite a large portion of your overall data warehouse, of your overall data lake storage.
Going back, right, the data deletion is probably the single biggest use case that propelled this category mainstream, I would say. For Hudi, like I mentioned, things like MO, merge and read, and asynchronous compaction, indexing, the use cases, the motivations for building those things in Hudi was essentially a data deletion use case. So the main problem, if we can spend a little bit of time just like describing the problem, right? The data arrives in certain order, and for analytical queries, it kind of has to be laid out in a different way based on a query. But then often when you try to delete, it's by some other field. Like for example, you're collecting events arrive in some order, then your dashboards are grouping events by some dimension. So you want to probably sort or cluster that dimension, let's say for, again, from Uber, like cluster data by city ID and timestamp or something. But you want to delete data by user ID, which is kind of like what happens when a user leaves your service and says, these data privacy laws, you're required to go and delete all these things. So the indexing does help. The record level indexes approaches that we taken with external indexes and whatnot do Bloom filters. They help you identify quickly all the files that given record is present in, like a given user record is present in, right? But still, going back to what you were mentioning about write amplification, companies cannot afford to rewrite entire records, right? Entire Parquet files. So that's where having a delta log, like what we do with MOR, just queue up all the deletes through like a period, and then later compact it every like few times a day, amortizing cost of all the rewrites. That I think is how far we've gotten so far, to be honest, right? because in some sense, what we really need is you you need a system where you're clustering recent data for query performance based on what queries are accessing. But as you age them, you are also clustering by user ID or something in a way that is more conducive for deleting data, right? And these things are not platformized well today, even with Hudi. Like, people are building and cracking their own recipes to do this. The other thing that I've seen people do with Hudi is Hudi allows you to do partial merges, right? Instead of logging full deltas, you can write code to customize Hudi to say, okay, I needed to do data deletion or masking, but I only wanted to mask this one column out of 100. So instead of writing all the 100 again, you can actually log just the one column, right? And then merge it flexibly for queries on the top. So these are things that Hudi helps you do. And now zooming out a bit, this is all at a single table level, correct? How do you now generalize this across a data lake architecture where you have raw tables, bunch of jobs deriving tables? The thing is, this is where I feel for us, moving to a more incremental or borrowing from stream processing is going to be the better approach for us to solve this generically. And for example, if you were to send delete records in every chain stream, and then your ETL jobs are all actually processing them, right? At least a good chunk of use cases you can actually delete automatically. For example, for some use cases, we did soft deletes with nulls. So when you do an incremental query, you'll get a null for that user or someone. Then you just upsert the downstream table. It gets deleted and downstream automatically. Nobody has to do any manual intervention, right? You update the raw table, the downstream table is deleted. Okay, but still rudimentary. But if you do it with help of a stream processing framework like Fling, which has watermarks, helps you define a lot of reconciliation policies and all of that, you can actually write intelligent things where you say, this thing got deleted. Now I have a pipeline which is doing some aggregation. What portion of the output should I recompute, right? This is what stream processing frameworks actually solve very well. And that's where I feel like the future should be bringing all these primitives to just bash data. And then Hudi's role here is to simply provide optimized streaming, optimized lake storage so that you can actually write these programs, right? And that's, I think, how we solve it in a less gnarly fashion. And I think this is a very, very hard problem, even comparing to data warehouses, because people typically keep large scale event data in data lakes, right? Not warehouses. So maybe you can afford to delete data from all your cloud warehousing tables even, but on the lake, it's too much volume to rewrite all this data. It's still open, in what I'm saying. That's all I'm saying.
So in terms of the migration path for somebody who has an existing data lake and they want to adopt Hudi because of some of the guarantees and use cases that it enables, what is the process for actually migrating into that format? And what is the level of support for being able to have a heterogeneous set of tables where some of your data is using Hudi, whereas other tables are using Delta Lake or Iceberg or Hive?
There's really two questions here, right? First is, I have a bunch of Parquet tables. How do I bootstrap it into Hudi? So we have a feature called bootstrapping, where what we do is we don't really touch or copy the source data. So you can keep even writing new data to that table as long as you don't do destructive things. Hudi will essentially mirror that logical structure into a Hudi table and just generate indexing information out of the initial table, which is fairly quick. And as you write data, we will use the source data as external base files. And then as you touch portions of your older data, right, it'll all move slowly into the Hudi table. And this model lets you actually keep running two pipelines in parallel. Like a Hudi pipeline keeps, just writing to the Hudi table. The old data is kept kind of immutable, and you can, add new files to it also if you want. And then you can do count verification for the two tables. And it's a very practical way how data engineers actually perform data migrations. So all of this functionality is what Hudi supports. it's integrated into, for example, the Spark writers, like the Delta Streamer tool and all of that. They all have an option where you can say like bootstrap, and then for the first write, it does all this bootstrap, and then it gives you a table that is functional already. That's typically what you do. That said, I actually see a lot of people also generally full migrating even because of following reasons. One is Hudi does things like file size management for you, right? Which reduces the metadata overhead or the listing problems by significantly. It can be reduced by that. So maybe your old data is not, and many companies now they have more awareness around these problems and how this affects query performance. They feel like you're getting a lot more with these frameworks that they're even willing to full migrate their tables once. I see that actually surprisingly a lot than what I would imagine people would be willing to do. The second part of the question was more around interoperability for different, table formats, and do we see a polyglot world? I do think there will be a polyglot world for the following reasons. I mean, I can say we'll have every capability other formats have. Other formats can say we can have every capability Hudi has, right? I'll leave that out. But as it stands today, right, Hudi is best in class in terms of, CDC, quickly ingesting on our format. I'm just talking about even just the lower level design, the table format layer, as we talked before, not even including all the rest of the other platform functionality. Our format is the best suited for kind of like large scale streaming data from operational systems into a lake, right? And very quickly, because we have indexing, all of these other things. So I think for a company, I would imagine they have all of their raw data in a like system like Hudi, where it gets data in quickly and exposes streams quickly, right? So a lot of the impedance mismatch that you have gives you a very well managed raw data layer that's much more voluminous typically, right? And kind of like exposes these things for batch jobs as well. Now you may be a Databricks user. I mean, that's the other thing, right? All of the functionality that I talked about here is all tied to the Databricks runtime as a paid feature in Delta Lake. It's not really like it's open format, but it's not an open runtime, right? So maybe you would want Delta Lake for derived tables because that's when Delta Cache will work for you, right? The Databricks runtime, generally the Spark jobs you're writing within Databricks are optimized to work on the Delta format, if you will, right? So maybe for derived data, you end up picking Delta Lake, and then for similar reasons, maybe people want to pick Iceberg for their derived data, right? For batch pipelines, and then you can do the same batch placement with Hudi as well, right? So that's how I think there are sets of users for these batch derived data pipelines where they would pick any of these three formats for derived data. But I feel like tying together all the different things that we discussed here, right? From, how does stream processing, like incremental streams, fit in data deletion? How does it derive efficiency? As the incremental stream processing kind of like model grows more and more and becomes fully mainstream for even data lake processing, we expect like most of this data to like derived data to kind of like sit in Hudi. So to support that, you need much more than just a table format. You need like a runtime and all these other functionalities. Where I see the future going towards, right? That said, it'll be great. I think maybe like there's some scope for consolidation here, where if we can fit some of this other functionality on top of like Delta or Iceberg in Hudi today, even for batch jobs, people can make use of like these services, right? And they are, in case of Delta, they are open. You're freely available. You don't have to like really tied to the Databricks runtime if you don't want to do that. In terms of Iceberg, you don't have these capabilities. So all these services are already built. They work well oiled, running in production in many places. So yeah, the Iceberg users may be able to get a lot of this usability and operability around their format for free. So that's another angle that we are thinking about. And it's a tricky kind of conversation, but I think that's a better model. Again, big picture, the lakes have to get better at this stuff. If we were to build the kind of the open data as a vision for our future, and at least I'm personally open to taking any contributions. I'm pretty sure the Hudi community will also have similar opinions. I can't speak for the community at large, but personally, yeah, I'm open to take contributions that even take us along these paths.
As somebody who has been involved in the Hudi project since its inception, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
Recently, there was a very interesting kind of proposal slash use case. I actually spent some time researching into it, and then I think it makes sense. It completely came out of left field. So if you look at event streaming systems, so we've been talking a lot here about stream processing and Hudi and mixing like batch stream processing and all of that. And this is also like a testament to something like that, right? Where event streaming systems over time have kind of done the reverse, which is they've built tiered storage into their models where you have like a stream processing program, it needs to backfill now. So our bootstrap. Now you need to run it on also the historical events and they need to consume those events in that same order, right? So I think pretty simultaneously from people in the Kafka and the Pulsar community around, hey, can we back the tiered storage in Kafka or Pulsar or the event streaming systems with something like Hudi? Because you get transactionality, you get like a Kafka style offset that you can tail data by, you get columnar data because oftentimes streaming queries are also right, only selecting a subset of columns from the data, right? It may be okay to do row oriented processing when you're doing like record by record, columnar probably will add latency, but when you're doing like historical events, when you're consuming them, you can, by pushing projections and filters down to a system like Hudi, you can actually gain ton of efficiency in terms of the amount of data that you bring down from cloud storage and tiered storage for your processing. So that was like, to me, something that made me very happy because it kind of like, for me, like completed the circle of, okay, yes, like I've been saying stream processing with data lakes, but then for someone from like the stream processing, event streaming world to recognize how we are filling the gap from that lens was very, very interesting and gratifying for me.
In your experience of helping to create this project and iterate on it and continue to contribute to the overall ecosystem, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
The community process, right? So we have been in open source for almost 12 years now, but this is my first time kind of growing the community and sharing that responsibility of making sure everybody in the community is able to do what they want to do. And there are lots of lessons for me just in terms of how we interact with people, what are people looking for, right? Sometimes you're working in a lot of these like large tech companies, like you're architecting big systems, and then for me it was an interesting experience to go spend these 4 years that I have spent with the community, kind of like very one-on-one, helping people who are probably learning the fundamentals and trying to build all of this themselves. I would say I learned a whole bunch of interesting lessons around the community building and that aspect of open source, which was very fun to see firsthand. And then I believe in open source more than I ever did before after this journey.
For people who are considering Hudi for building out their data lake, or they're trying to figure out what structures to use for being able to organize the data that they may already have, what are the cases where Hudi is the wrong choice and they might be better served with a cloud data warehouse or Iceberg or Delta Lake or any of the other options that are out there?
Yeah, so I would say starting from, since you said like the analytic data lake workload, of course, I've had cases where people want to use Hudi as from an online system, right? Because we have HBase and we have index file formats there as well. So that I think would be like a wrong use case for OLTP scenarios out of the bat. When would you use cloud warehouses as opposed to using something like Hudi? I mean, end of the day, Hudi provides a data plane, which is like, very functional. But the value that you get for your queries also depends largely on the query engine itself, right? So I think that will dictate this more than the cloud warehousing. Right now, I would say in Hudi on the platformy components, we don't have few components that cloud warehouses already have, like encryption service or like a couple of things like that. I think for now, if you really need those things, yeah, you would probably find them readily available in a cloud warehouse than the Hudi project. In terms of the lower level format itself, I would say if you are, and this is what's actually happened as well, right? Large companies, for example, they have their built-in systems where they just want to commit files. That's what they want to do. They don't want the indexing, pre-combining, like none of that kind of thing. Like Hudi does make life easier for the regular data engineer far more than the other formats, in my opinion. But if you're a large company, let's say LinkedIn, you already have Goblin, right? And which is an ingestion system there. You don't want to change Goblin at all. You don't want to move from Goblin to Delta Streamer tool, but you just want to commit files. Yeah, Iceberg has a nicer lower level API for that, which we have not invested in before, right? We are thinking about opening these things up, but again, I feel like the future is more around, you know, how do we help all the other companies that cannot afford to build their own Goblin to kind of like do these things out of the gate. So we are focusing a lot more energy on that. So you may see a lower level format for API from us, but we are prioritizing differently. So if you really, really want something which commit files, then yeah, Iceberg probably has a better, lower, flexible model. And yeah, that's about it. But every other case, I feel you will get a lot more bang out of your buck by picking Hudi. I mean, we commit files to Hive, so we can also commit files to Iceberg or Delta, right? Unlike, it's not like the Parquet versus ORC war or like this battle where it's actually about data, right? This is like metadata. All systems store data in Parquet files. So whether you Hudi stores it in an internal metadata table, Iceberg stores it in an Avro file, Delta stores it in a JSON file, you can easily go between these things. If we do these things, maybe you can probably get the benefits of the formats, but again, it's a means to an end, but you continue to use the upper functionality of Hudi to ingest data right readily, and then you can interrupt with these formats, right? That's again like probably a vision that we should build towards, and it does need some cross format collaboration across these projects as well. And I really don't want to approach this from the Parquet versus ORC kind of like mindset that went on in the height of the Hadoop vendor wars. I think that was very detrimental to the entire space. That's I know it's aside from your original question, but I just want to like register this here, right? That I think we should have it all in open source. We should collaborate and see what benefits the community at large.
Absolutely. Definitely something worth calling out. And then in the Iceberg ecosystem, they added in the Nessie project for being able to get some of the kind of snapshotting capabilities and have more of a Git style branching and merging capabilities. And then there's LakeFS for doing that on arbitrary files in S3. And I'm just wondering what your thoughts are on the relative utility of things like that versus the MVCC support of Hudi, or the potential benefits of bringing in some of those branching and merging and snapshotting utilities for Hudi itself.
So Hudi does have some snapshotting kind of export, import kind of like utilities, but they're all designed more like around like database backup-y kind of like things like DR, restore kind of thing, right? That save points and things like that. We do have utilities for those too as well. I think Lake FS already supports Hudi, and Nessie, there's a ticket open to support support Hudi as well. So yeah, those are things I think we want to do over time. Again, recognize Hudi tables, we'd rather do that than try to duplicate their functionality, right? I do think that these are like separate use cases though, where one is the branching kind of thing. Again, if you go back to it, right, it's mostly for immutable data set. It's like a more distributed DVC kind of use case where you want to keep versions of data for you to play with. We haven't really focused on that scenario a lot. We focused a lot on, hey, like lots of updates, deletes, streaming data coming in. Once you have like a lot of these deletes and everything, I don't really think anyone has solved the problem in the context of all of these things, right? So in short, we would like to integrate with Nessie as well. We have a ticket open, but more and more, I would like to understand, for example, how you build these things on top of like data warehouses, for example, right? Do you really care about file versions anymore on the lake? Like, do you really need to deal with file versions? Or can we just work with like, okay, yeah, I took a backup or a snapshot of this table. I worked on Oracle code base. That's how Oracle was. So we built every single database. Like this is my fourth or fifth database project. That's how everything felt like. So philosophically, I'm a little bit conflicted around what is the right interface for these kind of use cases. But yeah, I mean, with open arms, we'll integrate into other systems as we get more resources.
All right. And you've touched on this a little bit already, but in terms of the near to medium term future of the Hudi project, what are some of the things that you're particularly excited for or that are worth calling out for people to pay attention to?
I think in the near term, We've had like a streaming write API for a while, like true to kind of like how we started, right? We're introducing a SQL layer now with Spark SQL. We're starting with that. And then we are like also packaging like upper level functionality, like clustering compaction. All these things are packaged into the language as well. So we are hoping that makes life a lot easier for people. And it does interop with tools like Delta Streamer. So you can be doing that for ingesting the data very quickly, and then maybe you want to do a delete, and then you can drop to a SQL prompt and do that, and makes life much easier. So I think that is something that we look forward to, and we are doing a lot of things around record level indexes. We are adding a lot more indexing capabilities inside Hudi, and there's a PR already out for record level indexes, which let you, without an external key value store, we can quickly take random updates and be able to apply them quickly to your tables. And I think someone just opened PR for Z-order indexing, kind of like more clustering strategies that are, out of the box on your data sets, right? All these functionalities are coming to you in the short term, I would say. In the medium term, we still do see some gaps when you compare what Hudi provides to something like a cloud warehouse, where like the metadata scaling, the way the metadata has been designed in the batch formats doesn't really work well when you're trying to do a lot of frequent commits in Hudi. So we're thinking about, we have a meta server already. We call the timeline server. We run it embedded within every writer to kind of deal with the more voluminous metadata needs that we have. We're thinking about actually extending that a bit and providing a recipe for running it standalone in a Kubernetes cluster, so that you have like a more scalable metastore backed by a database like RocksDB, which is like much more performant than reading files from like a file system, right? So that's another project. And we are also thinking about building out kind of like a mutable Hudi aware caching layer. The other problem is you can write a lot of small files to, like quickly ingest data, but then on the query side, you need to open and close a lot of files, right? And then you still pay some merge costs when you're merging data. So can you amortize all that? Can you build the buffer pool for the data lake, if you will, right? That's another thing, that angles that we're looking in. And we are investing a lot more in Flink, ability to even pass in, going to your point about how do we do data deletions across the lake. So we are now passing in the operation flags. So something like Flink dynamic tables can now, recognize all these flags and apply all the deletes and everything. We are evolving our incremental queries to be more and more like a Debezium log that you get out of this, right? Full-blown CDC capabilities. And these are all in line with our vision for, hey, let's incrementalize all of the batch workloads. That's kind of where we're going.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I would just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I think the common theme from even our conversation today, right, which is we need more self-managing systems, and we need more ways of platformizing the data ops workload, that, if you will. We've designed, at least in the data lake ecosystem, more general purpose things that let you read and write data, and we haven't really done a good job of platformizing classes of read-write workload into like upper level tooling as much as we would like. So I think that's where we need to focus a lot more energy on, and then help make, whether you call it a data lake or I call it a streaming data lake or a lake house, whatever you want to call it, it should be easy to get up and running with that. And I think for that, we need lots of things to build.
All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing on the Hudi project. It's definitely a very interesting set of technologies and an interesting architecture. So I'm definitely very excited to see where it continues to go in the future. So thank you for all the time and effort that you've put into that. And I hope you enjoy the rest of your day.
All right. Thanks for having me. And yeah, greatly appreciate all the questions.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.